Hello, everybody. This is Professor Ma, and this is the section on more computations on derivatives. So, last time we defined derivatives, and in these sections, uh, all the prime operations will be with respect to the letter x, and all the formula will be with respect to x until we get to the sections on chain rule. Okay. So the following rules are from last sections. We have the derivative respect sum and difference, and the derivative respect constant multiple. So I can have those two rules. And then we have the product rule and quotient rules. Okay. And in particular, we have the following formula for derivatives. And for the constant function, the derivative is 0. And for the power function, x to some power p, and then the rule is the power comes down, p comes down to the front, and then you take one away from the power p. Okay. Assume p is not 0, of course. So, and in these manners, from default from the rules we just went through, it allows us to take the derivative of all the algebraic functions. Okay, that is all the functions, rational functions, and radical roots and stuff. So next, we're going to do is we're going to talk about the basic derivative for the trig functions. The derivative of sine of x is cosine of x, and derivative of cosine of x is minus sine of x. So we're going to derive over here, and the first one, derivative of sine is cosine, and it basically came from the addition rule for the sine, and the sine of the sum of two angles, and these two particular limits. These limits is probably the most important limits that we introduced in back a couple of seconds ago. This is limitizing between the functions, algebraic function x and the sine and the trig function sine of x around 0. They basically got the same. So it's very important. And the other one I leave as homeworks, and as h go to 0, you're going to get that limit to 0. I left as homework, and the hint is conjugate, use conjugates. See what happens. Okay. So here's the sine x version. So I use the difference quotients f of x plus h. So in this case, sine of x plus h. But by the way, I use this little s and just for sine, and minus sine of x, right? And that's the difference quotient. I'm going to divide this by h. But by the formula for the sum of angles, I can write sine of x plus h in this form. So carry the algebra up and pull the sine of x out of group them together, and then I can write the difference quotient in this format. Then I break this format into two pieces. And the other limits we have on last page, and notice it shows up here. That is, we said the limit of this is 0. Okay. So, and the limit of this is 1. Okay. So the limit is from 0, so 0 times 0, say so 0, and the back is the limit goes to 1. So what's left is just cosine of x, and this is the limit for the difference quotient of sine of x. In other words, the derivative of sine of x is cosine of x. Similarly, you can prove that the derivative of cosine is like a minus sine. Okay, we basically just change this rule of sum of sine and sine of sum of two angles into using the cosine formula for the sum of two angles. Okay. Now, from there, then we can extract the derivative of all the other trig formulas. Well, the reason is because all the other trig formulas are basically divisions dividing sines and cosines. Okay, the reciprocal 1 over sine, 1 over cosine, or sine divided by cosine, cosine divided by sine. Those are the other formulas, meaning that we can apply quotient rule to obtain the other derivative. And so here's a list of a derivative of the other trig functions. And on the bottom, I give you the derivative of the log and exponential function, just so we can do homework exercise and learn all the mechanic how to take derivatives. Okay. And so here's a derivation of derivative of tangent using the quotient rule. Tangent is sine x over cosine x. So using high d low minus low d high divided by low square. Okay, and the derivative of sine is cosine, derivative of cosine minus sine, and cosine squared plus sine squared is 1. So that's one of the most important trig formulas. Okay, it's going to, yeah, remember that one. Okay, if any formula you want to remember in trig is sine squared plus cosine squared is 1. Okay. And then you get the derivative of the tangent is secant squared. Okay. And similarly for cosine, derivative of cosecant, we use the quotient rule. I will obtain the formulas derivative of cosecant minus cosecant cotangent. Okay. And want to point out, let me go back through the list of formulas in the trig formulas. All the derivative of the co-formula. Okay, derivative of cosine is negative. Derivative of cotangent is negative. Derivative of cosecant is negative. So the co-trig functions, they all have negative derivatives. Okay. So that helps a little bit in we try to memorizing all these trig formulas. And there's some symmetries in the derivative, so it's easy to memorize. Okay, not hard to memorize. And here is how do we find the derivative of tangent square? Well, we could one way to do it over here is interpret tangent square as a product, tangent times tangent. And then I can apply the product rule, and now I'll get the derivative of tangent times tangent twice. Okay? And then the derivative of tangent is secant square, and that's the derivative, okay, of tangent square. This is what I call a two-layer composition problems. Okay. From here, can you apply the same rule for f, some function f you want to square f squared, then the derivative will be twice f times f prime. And this is actually what we're going to go into, the chain rule. Okay. So we know how to take derivative of formulas as long as it's made up from basic formula like polynomial times sine at the trig formulas divided by cosine. As long as everything is made from those formulas, I know how to do this because basically this is quotient rule, then product rule, then power rule, then etc. We can break it down into the derivative. And there's one more step that we use to make formula, that's compositions. How does composition shows up on the derivatives? Okay, in here is where the chain rule came from. Okay, so suppose I have a formula U, and it's a formula based on the letter V. It's a function in V, if you like, and the function, then the V actually itself is a function based on X. Okay, so it's a two-layer formula. So for example here, let's use as V squared. Okay, V itself is tangent of X. So if I want to link directly from U all the way to X, then U is V squared will be tangent square of X. Tangent X squared. Oh, by the way, we always write these, well, not always, a lot of times in the books, we write these as with a square over tangent, then the argument x. So whenever you see these, you should remember the squaring is the outside, the tangent is being squared. Okay, so if there's a cube there, then the cube. So here, anyway, this here is tangent square of x. That is what u in terms of x directly. Okay, and the question is, how do I take the derivative of this formula with respect to x? And here's what Chen Wu says. If this formula is a composition of u and v, then the derivative of the compositions is going to be the product of, take the derivative of u with respect to the letter v, take the derivative of with respect to x. They each have their own variables, and then multiply them together, and this is derivative. Of course, the front part is a formula in v, because everything is used in terms of v, and the second part is a formula in terms of x. Okay. So the finished product is a formula mixed letters. Then you have to convert them all into x. Okay. So here is how it works. This is one version of the chain rule. This is one way to do it. Okay. So here we go. We have u is v squared, and then v is tangent of x. So the derivative of u composed with v, tangent square of x, it's going to be du dv, which is 2v, okay? Times then the dv, whatever v is in terms of x is, the tangent of the derivative tangent of x with respect to x. The front part is 2 times v, and the back part, or the tail, I will call it, you understand why I would call it the tail. This back part keep popping out. It's the derivative of tangent secant square. And that's it. And then what's v? V is tangent of x. Now we put the tangent of x back. So this is one way to do chain rule. Later on, we have other way to view the problem. Okay. So here we go. Here are 2 different examples with 2 different formulas, but they are in 2 different versions of the being interchanged. Okay. So y is a formula in terms of u. U is a formula in terms of x. So y in terms of x directly is going to be, instead of u here, x cubed here. So it's going to be sine of x cubed. Okay. So this is the formula y directly in terms of x. And the questions ask you, how do I take the derivative of these formula compositions? Okay. And so what is dy dx? Well, the answer is, well, it's come from 2 parts. You just first make a stop at dy du, since y is defined of u in terms of u, and multiply that what u is defined in terms of, in this case, x, and du dx, and at which point we stop, because we're taking derivative stop at x. Now I look at dy du, that's cosine of u, okay, and then du dx is 3x squared, and these 2 will multiply this. That's what the chain was saying. Multiply these 2 derivatives. That's the derivative of the compositions. Of course, that I want to put the u back. Okay, cosine of u times 3x squared, and the u itself is x cubed. Put x cubed back with u. Now, the next one, and say find the derivative of sine x cubed. Now, the order is different. This one, we're talking about y is some, so y is equal to somebody third powered. Okay, so therefore, y is a function of u, which is u to the third power. And what's the u? U is the base, sine x. So the chain rule, the derivative of sine cubed, sine of x cubed is going to be derivative of 3u, u to the third power is going to be 3u squared. I take the derivative of that. And the derivative of sine of x is cosine x. And that, of course, is going to be the derivative of sine y of x. Okay, it's a product of these two things. So, okay. The general chain rules, and so the examples we just went through basically are two layers. In this case, sine and being cubed. Okay, you cube first, then do the sine, or you do the sine first, then cube the sine. Now, here are multi-layers. The chain rule just says if y is in terms of u is in terms of w, blah, 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 then if you want to take the derivative of y in terms of the last input variable x, you just multiply the derivative of each state. Okay. Y in terms of u, u in terms of w, w in terms of whatever, until the last one, v in terms of x. Of course, the front part, they are all in different letters. They are in u and w and blah, blah, blah. V is blah, blah, blah. You have to replace the x back into all what they are. Okay. Here's a three-layer one problems. Okay, that is or this way we're going to do this problem from outside in. Later on, there will be another way to do the problem inside out. So this, let's do it from outside in. What I mean by outside, if I look at this formula, I pretend this, I don't know what that is. Basically, this formula, the last things you need to execute is x cosine of something. Okay. That something is what we call the u. Okay, so the way to set this up is we look at the last executions, the function, the basic function for the last execution here is cosine x. So cosine u. Okay, so therefore I set y, the first one, to be cosine u. Okay. First layer. Then the u, then I take a look at what the argument is. The u now is x squared plus 1 cube. So u is somebody cube. So therefore, the next things to say, u is some other basic formula to the third power. Okay. Then finally, who is third powered? V is x squared plus 1 is the base for the third power. So therefore, this is the three layer for these compositions. Okay. Now, what's the derivative with respect to x? And the chain rule says derivative with respect to x is going to be derivative of this is going to be minus sine of u. Derivative of this is 3v squared, and derivatives of x squared to x. And the derivative of this whole thing with respect to x is going to be take these three things, multiply. Okay, and this is the written out horizontal. And this is another three-layer versions. Okay, this time we're going to do it from inside out. That is, we're going to pick up the x and see where x goes first. And in other words, we're going to do this by mechanically algebra. We're going to do it this way. Okay. So the x, let's find out the trips the x go through these formulas where the input x, what it is going to encounter. The first thing x is going to meet is the log of x. So let me call that u. Okay. And what's happening to the log of x? Oh, after we get u, we're going to square that thing. So it's going to take u squared. Why? Because log of x squared inside out. And let's call that v. What happened to v? V is going to be sent to the sign department. It's going to be sign of v. So the output I call it, give a name for it. And the question is asking was dw dx. Okay. Well, then again, chain rule says just take the derivative du dx, dv du, and dw dv. Okay. Each one of these. And those are all basic functions, and they are very simple forms, so it's easy to write them all out. Okay, and then you put x back into them. So this is versions inside out chain rule. These are the versions using the circle composition notations. It says compose the functions u and v, then what you're going to have is a derivative u prime times derivative v prime. However, you got to be a little careful here because these two derivatives meant respect to different variable. The composition derivative is to respect to x, is the product of the derivative respect to the u respect to the v. Okay, so this is derivative respect to the letter v, not to the x, times the derivative v respect to the x. So this prime is you have to be a little careful in interpreting that first layer. Okay. So u prime means du dv, u respect to v. And then this is the examples using cosine this is cosine of x squared. Okay, v is x squared, and I put x squared in v in here, so this cosine x squared. So we're taking derivative of cosine x squared. It's the derivative of cosine of v times derivative of x squared. Derivative of cosine v is minus sine of v times 2x. Derivative of x squared. V is x squared, put x squared back, like. Oh, evaluated at x equal to pi, then we're going to get sine of pi, which is 0. Okay, so this is exercise kind of, it's worthwhile to go through the symbols, match which pi is which pi for the algebra. And then finally, the chain rule. It's a very simple rule. Basically, the composition basically is as this. If y, for instance, think of exchange rate. Okay, let's suppose I can take $1 exchanging to 10 pesos, and each peso changing to I don't know, five gigabytes, whatever gigabytes are. Okay. Gigas, yeah. So then what's the exchange rate directly from $1 to the gigas? Well, you're going to take 10, the exchange rate to 10 peso. Each peso is 5 gigas to multiply by 5. Then the answer is $1 is equal to 50 gigas. Okay. And this is exactly what compositions say. You exchange one variable for another variable, and then the effect is the multiplication of the rate. Okay, so in this case, if I use linear function, then the composition is 3 times 5x is 15x. So the slope becomes 3 times 5, 15. And that's the essence of the chain. Okay, that's it. Bye-bye. Do the homework, and until next time.